show that fz equal to xy plus iota y is everywhere continuous and also it is not analytic. When the function is not analytic, if CR equations, that is the Cauchy-Riemann equations, are not satisfied. If these equations are not satisfied, then we say that function is not analytic. So here we need to check that whether Cauchy-Riemann equations are satisfied or not. And if Cauchy-Riemann equations are satisfied but at all the points, then we say that function is analytic, right? So let's start with the solution. This is the function given to us. Let's write its imaginary and real parts. So let u plus iota v be equal to xy plus iota y, right? So its real part is xy and its imaginary part is y, right? Now because u is a polynomial in x and y, v is also a polynomial in y, so these two are continuous. Why? Because every polynomial is always continuous and is also differentiable at every point, right? Because these two are polynomials, we say that u and v are continuous. And if u and v are continuous, we say that u plus iota v is also continuous. That means the function is continuous everywhere. Very fine. Let's write this. Since u and v are polynomials in x and y, this is the first part we are doing. So therefore, u and v are continuous everywhere. Why? Because every polynomial is always continuous everywhere and is also differentiable at all points. So thus fz, that is equal to u plus iota v, is continuous everywhere. So first part is done. Yes. And now we need to check whether Cauchy-Riemann equations are satisfied or not. We need to prove that the function is not analytic. So for this, Cauchy-Riemann equations should not be satisfied. What are the Cauchy-Riemann equations? The CR equations. It is partial derivative of u with respect to x should be equal to partial derivative of v with respect to y, the first equation. Partial derivative of u with respect to y should be equal to negative of partial derivative of v with respect to x. It is the second one. So let's check this. We have u to be equal to xy and v is equal to y. So partial derivative of u with respect to x is y and partial derivative of v with respect to y is 1. And from the first equation, partial derivative of u with respect to x is not equal to partial derivative of v with respect to y, right? So there is no need to check the another one. It is simply proved that CR equation is not satisfied. So Cauchy-Riemann equations or CR equation is not satisfied. So we say that thus fz is not analytic. So for the function to be analytic, CR equations should be satisfied at all the points of the domain. It is very important. It should satisfied at all the points of the domain, right? Not at one point, but at all the points it should be satisfied. Then only we say that fz is analytic, right? But here CR equations are not satisfying, so we say that fz is not analytic. Okay, thank you.